So, can we actually write a mathematical proof for a broken heart? Just think about that for a second. Mathematics is built on these incredibly rigid axioms and flawless logical proofs, right? It's exact, it is profoundly unforgiving. I mean, a single misplaced variable and the entire system just completely collapses. Human nature, on the flip side, is, well, fleshy. It's chaotic. It's driven by this massive swirl of conflicting emotions that, let's be honest, rarely make any logical sense. But what if the divide between those two worlds isn't actually as huge as we think? What if formal, rigid computer code could actually capture our human chaos? Welcome to today's explainer, the math of the messy, compiling human nature. We are going to take computer science, specifically formal compilation theory, and use it to literally map out the human condition. Let's dive right into this and see exactly how human biology, raw emotion, and massive crowds can be perfectly mathematically described by compiler algorithms. Okay, let's start with something you and I do every single day without even giving it a second thought, speaking. In the source material we're looking at today, there's this beautifully formal model called the gestural compiler. What it does is use something called articulatory synthesis to translate a purely abstract thought right into physical reality. To really wrap your head around this, think of a phoneme. That's the smallest distinct unit of sound in any language, like the sharp k sound in the word cat. Now that phoneme is just a pure abstract piece of data in your brain. The compiler's entire job is to take that abstract data and translate it into this highly coordinated, perfectly blended physical score of biomechanical movements. Basically, every single word you say is an algorithm. You are literally compiling abstract data into fleshy reality, forcing your muscles to execute a computational command. Now, to actually pull this off, the compiler software has to track some incredibly specific biomechanical parameters. And I mean granular. We're talking about calculating the exact x and y coordinates for your tongue's height and its backness, mapping out the precise degree of lip rounding and closure. It's wild. It even tracks the pitch, the pressure, and the tension of your larynx. And then it calculates something known as syllabic nucleus stress. The syllabic nucleus is basically the high-energy core of a syllable, usually a vowel, where your vocal tract just completely opens up and demands maximum acoustic power. Think about what's happening here. When you stress a word, you are executing a mathematical command that forces your wet, messy biological tissue to massively spike its energy output. It is just fascinating to contrast these sterile, perfectly defined variables of computer code with the squishy physical reality of a human mouth contorting to form words. When we dig into the actual lean code behind this, specifically the structure for the larynx state, it literally dictates the exact pitch, pressure, and tension required to produce a sound. Remember that syllabic nucleus stress we just talked about? Well, when you put stress on a vowel, the mathematical system actually applies a strict scaling factor. It mathematically multiplies the variables, which automatically increases the duration of the sound and boosts the laryngeal pressure by exactly 30%. It's not just a vague feeling of emphasis, it is a stunningly precise mathematical model of physical human effort. It's taking an abstract, qualitative feeling of verbal emphasis and mapping it straight into a rigid quantitative scalar multiplier. And honestly, this next part perfectly illustrates just how deep this math really goes. Even when you are saying absolutely nothing, when you are completely silent, there is a strict mathematical rule governing your anatomy. It's called the Schwa invariant. This formal theorem actually states that during periods of silence, the human vocal tract must return to a neutral baseline coordinate of 0, 0 for tongue height and backness. There is just a profound philosophical beauty in that, don't you think? It means that physical rest isn't just an absence of action. No, it is a mathematically required position. Even your most profound, quiet moments of human silence are formalized as a precise physical return to an origin point. You are constantly resetting yourself to a mathematical zero. So that's the individual mouth. But what happens when we scale this whole concept up to a massive group dynamic? What happens when humans start acting together in a massive crowd? The text looks at crowd applause and actually compares it to pure white noise. Now, pure mathematical white noise is this uncapped, completely uncorrelated ideal. It's a theoretical signal that contains equal acoustic intensity at every single frequency, stretching on indefinitely without any underlying biological limit or pattern whatsoever. Human applause? It actually sounds remarkably similar to this mathematical ideal, but it is fundamentally a biologically capped reality. Let's break down exactly why a crowd of humans fundamentally fails to achieve perfect noise. In the lean code, crowd applause is formally defined as acoustic central limit pseudo-noise. A lot of people intuitively assume that a single clap sounds kind of like a tuning fork, just a single sharp tone vibrating through the air. but the code proves that a clap is actually a broad spectrum transient, and the physics behind this are just amazing. The primary driver of the clapping sound isn't actually just solid tissue slapping together. When you bring your hands together to clap, you create a tiny compressed cavity between your palms. That sharp cracking sound you hear, that is actually the violent air jet flow venting rapidly outward as that hand cavity collapses. You are literally mathematically modeling a high-pressure pneumatic release. The anatomy of a single clap is beautifully mathematical. Every single time you clap your hands, you generate two very distinct acoustic bands. First, you get this low Helmholtz thud band, sitting somewhere between 250 and 500 hertz. Then, you get a high piercing crack band, way up between 2000 and 4000 hertz. But the true marvel here is the sheer speed of it all. The attack phase, which is that initial burst of sound, happens in under 1 millisecond. That is unimaginably fast. It completely escapes our human visual perception. The entire total dry clap is completely over and done in under 10 milliseconds. And get this, your hand geometry completely changes the underlying math. Using flat palms preserves transient energy, which creates a massive, broadband acoustic shock, while cupped hands trap the air, absorbing that energy and drastically lowering the resonance frequency. Okay, so what exactly happens when we multiply this and put, say, 64,000 of these independent claps together in a huge stadium? This is where the math of the masses completely takes over. An individual clap has what we'd call a pinkish energy spectrum. That basically means the low and mid-body acoustic energy dominates the high crack energy. But when you have 64,000 independent clap offsets happening all at once, the immense scale creates these microscopic, tiny timing delays. One person claps just a fraction of a millisecond before the person standing right next to them. And these tens of thousands of tiny, staggered micro delays start overlapping, completely filling in all the high-frequency transient bins that a single solitary clap leaves empty. The sheer overwhelming density of these micro-delays shifts the entire apparent acoustic spectrum of the crowd. It moved it from a pinkish thud right into a whitish, continuous roar. But here is absolutely the most crucial point to take away from this. The applause never actually becomes pure white noise. It stubbornly remains what the code calls pseudo-noise. And why? Because of our underlying biology. Humans have a hard, finite clap rate cap. We can only physically move our fleshy hands so fast, meaning that high-frequency spectrum can never actually reach mathematical infinity. Furthermore, crowds naturally undergo something the model calls Kuramato synchronization. You actually see this all the time in nature. Think about fireflies blinking in perfect unison across a dark forest, or pacemaker cells locking into one shared heartbeat. It is a phase transition where a massive crowd, without any central conductor or direction, will just intuitively slow their clapping rate down slightly to lock into a unified shared rhythm. Because our human behavior retains these temporal correlations and strict biological caps, we can closely mimic the mathematical ideal of white noise, but our shared biology strictly prevents us from ever perfectly achieving it. Now let's take a major pivot here. We've talked about the physics of the body and the crowd, but what about the high-level philosophy of the human mind? How on earth does a rigid mathematical theorem prover handle deep, agonizing human emotion? The source texts bring up the famous Roman poet Catullus. He documented an incredibly toxic, devastating relationship in his poem Carmen 85. He wrote, "I hate and I love. Why do I do this, you may ask? I do not know, but I feel it happening, and I am in torment." Just pause and think about the sheer depth of that ancient human agony. How in the world do you write a piece of logical working code for a paradox where a person is being actively destroyed by a feeling they can't even begin to logically explain? Well, the answer is actually visually mapped out in the code defining what is known as the negative witness. The mathematical system proves that you can have intense emotional torment, which is represented in the text by the Latin word sentio, meaning I feel, running right alongside a total complete absence of logical reason, represented by nescio, meaning I do not know. It mathematically creates an epistemic void right next to an affective chart. And an epistemic void is profound. It means the programming explicitly accounts for the state of not knowing. The system literally carves out a mathematical space to acknowledge that a crucial piece of explanatory information is permanently missing. And yet, amazingly, the emotional system continues to execute flawlessly anyway. This entire paradox is formalized as the Catullan configuration. It proves, mathematically, that a human being can assert both affective poles at the exact same time, hate and love, without forcing a logical synthesis between the two. See, in classical logic, opposing forces usually have to cancel each other out, or they have to resolve into a single, synthesized truth. But the Catullan configuration, it doesn't force a resolution. It completely allows the paradox to exist. It represents a literal hole in the formal logic where the explanation chart should attach but simply doesn't. You are left with raw phenomenology, the pure visceral feeling of torment, without any answering reason to anchor it. This proves that humans are structurally capable of running an intense emotional response simultaneously with a complete underflow of explanation. Our internal why variable can be completely empty, no, yet our emotional processing continues firing at maximum capacity. We are quite literally mathematically built to feel things we do not understand. Which brings us to a massive, overarching revelation for our explainer today. The exact same compilation algorithms that process computer software perfectly mirror how the human brain processes its everyday choices. It's called the human compiler algorithm, and it plays out in 4 distinct steps. First, our consciousness works by forking options. Your brain instantaneously generates multiple possible paths, actions, or words all at once. Second, we race them. Your neurons literally put these generated options into a computational race against each other, deeply evaluating which one fits the current context best. Third, we fold to a final decision. We collapse all those multiple possibilities into a single chosen action or spoken word. And fourth, this is the amazing part. We vent the unchosen options to the void. The words you almost said, they don't just magically disappear. They evaporate at the void boundary. They are processed, safely discarded, and vented by your mental compiler, so they absolutely don't corrupt your final action. Because humans operate exactly like these compilers, we actually share 5 incredibly deep formal properties with them. First up is positivity. No mental option you generate ever truly reaches 0 probability. There is always a non-zero chance of you taking an unexpected path. Second is convergence. The system eventually finishes becoming itself through constant iteration, much like how we form and solidify our personalities over a lifetime. Third, failure dominance. Our rejections and our mistakes carry far more informational weight in our brains than our easy successes do. Fourth is deficit learnability. The gap between where we currently are and where we optimally should be is constantly steadily decreasing as we learn. And finally, observer separation. The part of your mind that records your failures is computationally completely distinct from the part that produced them in the first place. I mean, think about that for a second. This is literally the mathematical proof of mindfulness. Actively iterating self-reflection forces your internal system to converge on a better version of itself, exactly like a software compiler constantly debugging its own underlying code. But that raises a huge question. What exactly are we converging toward? This introduces the ultimate metaphysical limit, mathematically defined in the text as the God gap. The God gap is the finite, measurable distance between local optimality, which is the absolute best a system can currently prove about itself, and global optimality, which is the true, perfect state that would require absolute, literal omniscience to actually prove. Think of it as a bootstrap deficit of knowledge applied to itself. A system can only pull itself up so far using its own internal logic before it completely runs out of perspective. It lacks that omniscient bird's-eye view needed to guarantee perfection. Now, you can shrink this gap through continuous learning and deep reflection, but because of the fundamental, hard limits of logic, you can never, ever provably reach a distance of absolute 0. To really ground this abstract concept in reality, the source data looks at a standard compiler named Betty. Betty reached her absolute best local optimum processing time at 0.726 milliseconds. But the theoretical, unprovable, global minimum absolute perfection was calculated at 0.065 milliseconds. Subtract the two and you get an exact upper bound on Betty's God gap, 0.661 milliseconds. Now, I know, that sounds like an incredibly tiny fraction of time, right? But in the incredibly rigid, fast world of computing, it represents a permanent residual. It is a measurable, completely uncrossable boundary between what Betty achieved completely on her own and what an omniscient creator could theoretically achieve. Betty is permanently, forever locked out of those 0.661 milliseconds. But look what happens with self-hosted systems. These are systems that are actually written in their own language and continuously compile their own code. A self-hosted compiler named Betty achieved a local optimum of 0.074 milliseconds. Compared to the theoretical minimum, Betty's God gap was an astonishingly tiny 0.009 milliseconds. The philosophical takeaway here is just staggering. Why does self-hosting drop the gap so drastically? It's because a self-hosted system continually iterates on its own architecture. It constantly analyzes its own internal flaws to write a better, faster version of itself. This deeply, beautifully mirrors human self-reflection. A self-hosted system that iterates on itself gets exponentially closer to the unreachable optimum. The compiler that continually finishes becoming itself is fundamentally closer to perfection than a general compiler that merely watches over other programs. Throughout this explainer, we've seen how rigid math maps our lips forming words, our hands clapping in a stadium, our deepest heartache, and our rapid decision-making. We are, at our very core, biological compilers. We are constantly iterating, debugging our own minds, and shrinking our own deficits. But we are always left with that final, tantalizing distance. So I want to leave you with this provocative thought to ponder about your own neurological compiler. Will we ever fully close the gap to our own unprovable global optimum? Or is that tiny, permanent residual of the God gap exactly what makes us beautifully, messily human?